Hi, this lesson is on special right triangles. When I say special right triangles, what I'm talking about are triangles that are either a 45, 45, 90-degree triangle, or I'm talking about, let's say, a 30, 60, 90. So let's say it's a 30, 60, 90-degree triangle. So I'm either talking about a right triangle that's a 45, 45, 90, or I'm talking about a right triangle that's a 30, 60, 90-degree triangle. These are what we call our special right triangles. So in starting, we're going to use the Pythagorean Theorem right here to find the missing side lengths. As we're going to look for a pattern to try to see if, we see a pattern while we do these. All right. So in solving this right here, we want to find the unknown side, which is x, because we know if it's a 45, 45, 90, okay, we know that two sides are going to be congruent, because if two angles are congruent, it's an isosceles triangle. 3 is congruent to 3. To use the Pythagorean theorem, we're going to go 3 squared plus 3 squared is equal to my third side unknown, quantity squared, my hypotenuse squared. So we have 9 plus 9 is equal to x squared. And so when I'm solving this, and I'm going 9 plus 9 equals x squared, I get 18 is equal to x squared. I'm going to square root both sides. And when I do that, again, remember, the square root of x squared is x. And just to reiterate this, I know we did cover this in class, but I want to remind you what a square root means. In a square root, let's say I have an x to the square root of x. There's a 1 here, there's a 2 here. So when I have the square root of x, this is actually can be rewritten as x to the 1/2 power, okay? So a square root is a half power. So when I have x squared and I square root of x squared, remember that's x squared to a half power, because a root, this root right here, is a half power. And so therefore, these are going to cancel. My exponents are going to cancel, and I just get x. So that's why x ends up by itself. The square root of 18 is going to be, I can break that down into the square root of 9 times the square root of 2. And the square root of 9 is 3. We have 3. Root 2 is equal to x. So this goes 3, 3, and then this now becomes 3 root 2. Okay, that's my third side. Now for this 45, 45, 90, again, these sides are exactly the same. We don't know what these are, so I'm going to call this, I don't know, x. So we're going to have x squared, using Pythagorean theorem, x squared plus x squared is equal to 6 squared. Leg squared plus leg squared equals hypotenuse squared. So 1x squared plus 1x squared makes 2x squared is equal to 6 times 6, which is 36. I'm going to divide by 2. I get x squared is equal to 18. And I'm going to square root both sides. When I square root, I get x is equal to the square root of 18, which is, what is that? That's going to be square root of 9 times the square root of 2. So x is equal to 3 root 2. So my x, this value is 3 root 2, okay? This is 3 root 2. Now this side here is 4 root 2, which means this side is 4 root 2 also, all right? So therefore, we got to try to find this value, which we don't know. We're going to call that x. Now again, these are the most tricky sides, because the biggest case of errors on tests and quizzes are squaring one of these. So just be really careful, okay? It's going to be side squared. So we're going to go 4 root 2 quantity squared plus that side, which is 4 root 2 quantity squared is equal to x squared, okay? Side squared plus side squared equals x squared. So what we have is 4 root, I'm going to do one of these because we have 4 root 2 times 4 root 2, okay? That is just this value here, okay? 4 root 2 times 4 root 2. Well, 4 root 2, 4 times 4 is 16, because numbers get multiplied with numbers. Roots get multiplied with roots. So we have 4 times 4, which is 16. Root 2 times root 2 is root 4, which is 2. 16 times 2, 32. So this value right here is 32, plus another 32. So far we have 64 is equal to x squared. I'm going to square root both sides, and I'm going to get x is equal to 8. So this is 8 now. There's 8. Okay? So what we have here is try to we've used Pythagorean Theorem, and we have, let's see, 3. Do you see a pattern? 3, 3, 3 root 2. 3 root 2, 3 root 2, 6. Well, what's the pattern? If I add it, see if these take this 3, and what I did was I took the 3 and I multiplied by root 2. Meaning if this was x, this is x, this would be x root 2. Okay? Well, if this is x and this is x, those are the same. What would be x, right? That's my x, root 2. That'd be 3 times 2, which is 6. Look at that. Same thing. If this was x and this is x, this value is going to be x root 2. Okay, let's check. 4 root 2, root 2. What's 4 root 2 times root 2? That's going to be 4 times root 4, which is 2. 4 times 2 is 8. Okay, so here's our little tricks, okay? So we haven't done any 30, 60, 90 triangle tricks yet, but for 45, 45, 90, if this is x, this is x, because these are isosceles, right? These are the same. And so this is going to be x root 2. So if this is 5, this is 5, this side would be 5 root 2. If this was 10, this is 10, this is 10 root 2. If this was 7 root 2, this side would be 7, and that side would be 7. So it's always going to be x, x, x root 2. But what happens, let me ask you this, what happens if it's not a root 2? What happens if on my 45, 45, 90, that this value here is like 10? What if it's not root 2? Well, let me show you what happens, okay? Just like on the previous page, I'm going to set this equal to x root 2. And you know that you want to solve for x. So that means that I need to get rid of this root 2. So I'm going to divide both sides by root 2. Well, in doing that, that'll cancel. I'll get x by itself. But remember, you cannot leave a root on the denominator. So you end up multiplying by 1, but in the form of root 2 over root 2, so that my denominator, what's root 2 times root 2? Well, that's root 4. Well, what's the root 4? What's the square root of 4? 2. So 2's on my denominator. This becomes 10 root 2. 2 goes into 10. 2 divides into 10 5 times. So I get 5 root 2. So one of my sides is 5 root 2. My other side's 5 root 2. So basically, the little trick is this. You have x, you have x, you have x root 2. X, x, x root 2. 6, 6, 6 root 2. But if it's not root 2, x root 2, and it's a whole number like this, see the 10? Now it's a 5, and I multiplied by root 2. So the trick is to take that number, whatever this is, divide by 2, and add the root 2. So this is going to be, if we had another right triangle that was a 45, 45, 90, and I said this was 8, we would take that number, and we would divide by 2, and multiply by root 2. So that would be 4 root 2. And if you remember from this previous section, see that 8? Divide by 2, we have 4 root 2. Now, the neat thing about the ratios for a 45, 45, 90 is it's really cool to remember the sides, but if you don't remember the sides, it's not the end of everything because, and the reason is because you can still figure it out. You can go, I don't know what the side is. It's x. We're going to call it x. We're going to go x squared plus x squared equals whatever squared, okay? But in the 30, 60, 90 triangle, it's a little different. Across from the 30 degrees, we're going to call that a. Across from the 90 is twice a. Don't get confused because you know a 60-degree angle is 2 times 30, but that's not the way it works. Across from the 30 degrees is a. Across from the 60 is going to be a root 3, and across from the 90 is twice a. So if I said a, somebody make another right triangle. This is my 30, 60, 90. So here's 30, 60, 90. So if I said across from the 30 was 5, that means across from the 90 is 2a. So that's going to be 10. And across from the 60 is going to be 5 root 3. Okay. If I said across from the 90 was, let's say, 14, And that's equal to 2a, right? What's a? A is 7. So across from the 30 is 7. And then across from the 60 is going to be a root 3, which is 7 root 3. Now, there is a trick to this one also, okay? And that is, what if this value was not like a root 3? What if it was backward? We work backwards, okay? So let me show you an example of that. So if I have let's say I have a right triangle, and my right triangle, okay, we have a 30, 60, and a 90. So we know, like, let's say that this was, let's say 5 root 3, right? Well, that would mean that across from the 30, if this is a root 3, right, that means a is 5. So across from the 30 is 5, and then across from the 90 would be 2 times 5, which is 10, right? But what happens if I said this side here was 15? Well, what would be my other sides? What would they be? So the rule is that you're going to take a root 3 and you're going to set it equal to 15, because that's what that side is. So I'm going to set 15 equal to a root 3. I'm going to solve for a, which means I'm going to divide by root 3 on both sides. And I'm going to get a is equal to 15 divided by root 3. Now, you can't leave a root on the denominator. So and I can't change the problem. Remember that. So I'm going to multiply by root 3 over root 3, because root 3 divided by root 3 is 1. And I can multiply by 1 in any form. So what I have now is 15 times root 3, and I'm still talking about this side. Let me erase this right here. Oops. Okay, so right now I have 15 times root 3, so I have 15 times root 3 over root 3 times root 3 is root 9, but the square root of 9 is 3, so this is over 3. So I'm going to cancel, so I get 3 cancels into 15 5 times. So this number here is going to be 5 root 3. So that's my a, by the way. Let me move that to where it should go. There it is, okay? So just be careful. If this value right here, across from this 60, ends up being a whole number, like 15, instead of like a root 3, the rule is that you can set it equal to a root 3 and solve it, or the rule is to divide by 3 and multiply by root 3 at the same time. And what ends up happening is you cancel, right? If you can, not everything cancels, and that makes a. So that means then that across from the 90 is 2a, so that's going to be 10 root 3. So let's do a couple more examples, because that's a lot to take in. Okay, so our 45, 45, 90, right? X root 2. So one way to do this is to use Pythagorean Theorem and go x squared plus x squared is equal to 8 squared. 2x squared equals 64. X squared equals 32. I'm going to square root both sides. 32 becomes the square root of 16 times the square root of 2. Square root of 16 is 4, so I have 4 root 2. So I know this side is 4 root 2. But again, and so is this side because, right, these are it's isosceles. But just keep in mind that the shortcut for a 45, 45, 90, which is a special right triangle, is you take your hypotenuse, whatever that is, divide by 2, and multiply by root 2 at the same time. So that's going to be 4 root 2, and so that's going to be one of my sides. The same thing for the 30, 60, 90. Remember, if it's a root 3, then that's super easy, right? A root 3, so a is 7. So across from the 30 degree, that's 7. And across from the 90 is 2a, and this is a, right? So across from the 90 is 2a, so that makes 14. However, if it's not like that, okay, so let me take this triangle. Let me copy the triangle. Okay, and let's say this triangle isn't 7 root 3. Let's say that this triangle was, let's say 21, okay? The rule is to get across from the 30, we're going to set this equal to a root 3, which is the same thing. The rule says, the little trick says, divide by 3 and multiply by root 3. So this would be actually 7 root 3. So across from the 30 is going to be 7 root 3, okay, because that's a 21 here, makes 7 root 3 here, and across from the 90 is twice that, so that's going to be 14 root 3. Okay, let's do some more. You can use Pythagorean theorem, or you can use one of your special right triangles, okay? So this is part of your homework packet, so let's try to do this. So, so if you use the little shortcut, you know this is a 45, 45, 90 because of the two congruent sides. So it goes x, x, x root 2, right? Because it's a 45, 45, 90. So we know this side is 2 root 2. So this side, right, is going to be, remember you're 45, 45, right? So the 45, 45 says this is x, and so this is going to be x root 2, all right? So you have x, x, x root 2. So this is going to be 2 root 2, this is going to be 2 root 2, and this side right here is going to be 2 root 2, root 2. Well, you're timesing those, you're multiplying, it's a product. So you're going 2 times root 2 times root 2. Well, that's root 4. So the square root of 4 is 2, so this is really 2 times 2, which is 4. Cool, okay. So now we have this, and this is an equilateral triangle, and that's 4, and it looks like this is 2. So it doesn't look like it's, oh, it is a special right triangle, actually, because if it's an equilateral triangle, then these angles are 60, right? Okay, which means that's 60, but when you cut it in half, it's now 30. So across from the 30 degrees is A, right? There's A. Across from the 90 is 2A, so that makes sense, because if that's 2 times 2, which is 4. So then across from the 60 is going to be A root 3. So let me show you again what you've got right here, a little bit bigger. What you've got is 2. You know this is 30 degrees, this is 60, and this is 90. Across from the 30 is A. Across from the 90 is 2A. And across from the 60 is A root 3. And you do need to memorize that. You should memorize it. So that means if across from the 30 is 2, right? Across from the 90 is 2 times 2, which is 4. And we already have that. We knew that. And then here, across from the 60 is going to be 4 root 3. So 4 root 3. A root 3, which is 4 root 3. So y is equal to 4 root 3. Okay? Now this one right here is Pythagorean. I could definitely use Pythagorean theorem, right? I could go 8 squared plus, remember, side squared plus side squared is hypotenuse squared. So 8 squared plus 15 squared equals z squared. But how many of you remember the triplets? Okay, remember our triplets? We've got, what do we have for our triplets? Let me just rewrite them. So we have a 3, 4, 5. We have a 5, 12, 13. We have a 7, 24, 25. And we have an 8, 15, and 17. And remember, in the previous videos, I showed you the little tricks here, but it's not a pattern because it doesn't work every single time. If it doesn't work every time, it's not a pattern. But this is a little pattern that I see, but again, doesn't work every time. 4 plus 5 is 9, square root of 9 is 3. 12 plus 13 is 25, square root of 25 is 5. 24 plus 25 is 49. 4 square root of 49 is 7. But what the heck happened here? It doesn't work. So it's not a thing. It's just something that I think of, but doesn't work every time. So it's not a thing. Okay. This actually, C is 17. But if you forgot, you can always work it out. So 64 plus 225, what is that? 225 plus 64. Add those up, we get 9, 8, 289, z squared, square root both sides. When you square root both sides, you get z is equal to 17. Super cool. We already knew that. It's a triplet. Okay, next one. 4, 5, and 6. So this looks like these angles are congruent, which means one thing, that it is a 45, 45, 90, right? Oh, it's special, right? So we have 45, 45, 90, which means x, x, x root 2. Remember the little trick? So that means that if that's 12, this is 12, and therefore this side is 12 root 2, okay? Now this is a rhombus. Rhombuses are my favorite, by the way. I'm going to make this rhombus bigger so that I can show you something. Okay, so we know that rhombuses have diagonals. They bisect each other because it's parallelogram. We also know, super cool thing about rhombuses is that there's a right angle right in between. The diagonals are perpendicular. If we know that's 30 degrees, by the way, we also know that's 30, FYI. If this is 60, these two, because it is a rhombus, opposite sides are parallel. So if that's 60, remember these have to be 180, right? So that means this total sum has to be 120, which will be 60 here, 60 here. Anyway, that also opposite angles are congruent, so that's 60 and that's 62. We have a 30, 60, 90. What do we know? We know that this is 6, so all sides are 6, all right? And so therefore, across from the 90, it looks like I have a 30, 60, 90. Remember the trick? Let me remind you, okay? Across from the 30 degrees is A, across from the 90 is 2A, and across from the 60 is A root 3, okay? So across from the 90 is 2A, and this looks like to me that that's across from the 90. So that's equal to 2A, which means A is equal to 3, okay? So across from the 30 is 3, there's 3. And across from the 60, which is this side, is A, which is 3, root 3. So 3 root 3. So what do they want to know? Looks like they want to know these letters. Now, personally, something that I might ask you would be, what's the length of the diagonals? So I'd say, well, that length is 6, right? Diagonal 1 is 6, 3 plus 3. And diagonal 2 is 3 root 3 plus 3 root 3, and that's going to be 6 root 3, okay? So just some ideas on that, okay? Now, what are we trying to find here? Looks like we're trying to find the height. These are 10, 10. Oh, this is an isosceles trapezoid, which basically means that these lengths are the same here and here. Okay, that's good to know. Because if this is 10, then this is 10 right here. Okay, so 22 minus 10, right, is 12. And if these share that value, that means this is 6 and that's 6. And how many of you recognize that this is a 6, 8, 10? It's not a triplet. Remember our triplets? 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. What do we know? 3, 4, 5. If I were to multiply this triplet by 2, I would get 6, 8, 10. So H is 8. Okay, so you see how that works? It's like no work at all. If you can remember your triplets, it's going to save you so much time. Okay. All right, let's do the next one. So we have a 60 degree. Oh boy, this is a 30, 60, 90. So this one, remember the little trick? Across from the 60 is A root 3. So if we have A by itself, we have 3 divided by root 3. Well, we're not going to leave a root on the denominator. So what we're going to do is multiply by 1, but in the form of whatever this denominator is, that's what I'm going to multiply by. Root 3 over root 3, because root 3 divided by root 3 is 1. And I can multiply anything by 1 without changing the problem. So root 3 times root 3 is 3 root 3. Now root 3 times root 3, right, is the square root of 9. Well, the square root of 9 is 3, so I'm dividing by 3. But root 3 divided by 3 is 1, so A is just root 3. So A, remember where A is? A is across from the 30. So this value is root 3. And across from the 90 is 2A, okay? So if this is A, then 2 times that is 2 root 3. And those are my answers. For this one, let's see here. This one's not as awful as that last one. Across from the 90, remember, is 2A, okay? I'm going to make this bigger because it's kind of small. And I'm going to split it up because we have two separate things happening. So we have this triangle here, which is a 30, 60, 90 triangle. Okay. So across from the 90, is 12. Okay. So remember, across from the 90 is 2a, which basically means a is 6, right? So across from the 30 is a, that's 6. Across from the 60 is a root 3. So if a is 6, that means across from the 60 is going to be 6 root 3. Okay? So now what we're going to do is I'm going to add this bottom part because we know, what do we know? That these are the right, this is a 45, 45, 90, because see the equals here, okay? So that's a 45, 45, 90. So I'm going to draw another picture, okay? And then here's my right angle. These are congruent. This is 12. So let's remember on this. If it's a 45, 40, I know it's a 45, 45. Some people, and I know that doesn't look like a 45. Let me fix this. So a 45, let's see, here we go. This will be better. There we go. And that was 12, by the way. Okay, so we know this is 12, and we know this is 45, 45, 90 because it's isosceles. And if it's a 45, 45 and right, then that has to be 45. Okay, so remember the rule? The rule said that we went x, x, and this was x root 2. Remember that? That's going to be x root 2. So you can set this equal to x root 2, okay? Or you can just remember what was that rule. If it's a 45, 45, 90, you divide by 2 and multiply by root 2, okay? If it's a 30, 60, 90, see this? You divide by 3. You divide by 3 and multiply by root 3. If it's a 30, 60, 90, the rule is to divide by 3 and multiply by root 3. Whereas in a 45, 45, 90, 45, 45, 90, the rule is to divide by 2, multiply by root 2. For the 30, 60, 90, divide by 3, multiply by root 3. Okay, so anyway, the rule is take 12, divide by 2, multiply by root 2. 2 goes into 12 6 times, so my side lengths are 6 root 2. Woohoo. Okay, but I could have done this, and see how I could have set 12 equals to x root 2? Let me just show you how that works. 12 equals x root 2, all right? If that's the case, I'm going to divide both sides by root 2, all right? Root 2's cancel. I get x equals 12 divided by root 2. I'm going to multiply by root 2 over root 2 because that's going to get rid of my denominator. Whatever root is on my denominator, that's what I want to multiply by over itself because that's 1. So that's root 2 times root 2 is the square root of 4, which is 2. Okay, 2's on the bottom. This becomes 12 root 2, all right? But the 2 cancels into 12, and I get 6 root 2. So 6 root 2. Same thing, right? Just another, but if you can't remember this rule, divide by 2, multiply by root 2, if you can't remember that, then you do need to know how to solve the problem. The last problem here is so small that I can't see it now. And it looks like, let me try to make this bigger. It looks, it's a 45, 45, 90. I know that because that's a 90 and that's 45, which means that also is 45. Now, the fun and easy ones are x, x, x root 2. So like, for example, if the length on the side was 8, that would be 8, and that would be 8 root 2. But that's not what I got. I got this. So what I have to do with this is remember the rule. If you have a whole number here, the rule is to get the other side, you're going to take 8, you're going to divide by 2 and multiply by root 2. So 2 divides into 8 4 times, so we get 4 root 2. So that's 4 root 2, and this side is 4 root 2. And but that being said, you guys remember with the 45, 45, 90, if you forget, right, there's your hypotenuse, which is 8, there's an 8. If you forget the rule to this one, you can always just call the sides x. That's completely fine. And then you would go x squared plus x squared is equal to 8 squared, right? Leg squared plus leg squared. and you get 2x squared equals 64. Divide by 2, you get 32, etc. So you can always go back to this and work that out, but the special right triangles are basically there just to help you try to find like shortcuts in order to solve the right triangle problems. So I hope that helps. I can do a couple more problems. I just want to just make sure you've got this down. We did a lot of the homework problems, but again, if I have a right triangle and I say, and this is a 45, 45, 90, again, 5, 5, 5 root 2. It's just try to remember, this is a special right triangle. It's 45, 45, 90. You have a leg, root 2. Okay, so that, let's say that's with 7, 7, 7 root 2, or 8, 8, 8 root 2. But if you don't, and even if this was like, let's say 3 root 2, right? This would be 3 and this would be 3. However, with a 45, 45, 90, okay, if you forget this side, or if you forget, you're not given this side, but this side is like 12, okay? How do you go back? You have two options. Option A is to use Pythagorean Theorem, right? This is I don't know. And that's so the same thing, right? So you'd go x squared plus x squared is equal to 12 squared, okay? 2x squared is equal to 144. Divide by 2. X squared is equal to 72. Square root both sides. You square root both sides. X is equal to 72 is what? 36 times 2. So 6 root 2. All right. So you can always, on a 45, 45, 90, you can always use Pythagorean Theorem. If you forgot the sides, you just call them X. I don't know what they are. I'm going to call them X. But the shortcut, so this B option, A was use Pythagorean Theorem. B is to use the shortcut, okay? The shortcut is to say divide by 2, multiply by root 2, okay? So for 12, I would have gone 12 divided by 2, and then multiply by root 2, okay? So that's going to be divide by 2. So 12 divided by 2 is 6, 6 root 2. Same answer, right? Sides are 6 root 2. Same answers. It's just a shortcut to getting there. And so for a 45, 45, 90 special right triangle, you're going to get there. It's pretty easy to do that. But for a 30, 60, 90, let's remind ourselves on that. 30, 60, 90 right triangle, okay? So on a 30, 60, 90, what you're going to see is, let's say that's 30, that's 60, that's 90. So across from the 30 is A, across from the 90 is 2A, and across from the 60 is A root 3. So if this was 5, this is 10, because it's times 2. This is going to be 5 root 3, okay? If this was 7, this is 7 times 2, that's 14, and this is going to be 7 root 3. If this side over here, let's say this side over here was 20, then going backwards, that side's going to be 10, and this is going to be 10 root 3. The problem comes in when this is not a root 3, okay? The problem comes in when that's like a whole number. Let's say it's 9, okay? Well, there's not really a way of figuring out the rest of the sides if that's 9. So you do need to memorize this. And the rule is, well, across from the 90, you got that because that's 2A. So 9 times 2, this side would then be 18, right? Oh, excuse me. I'm sorry. Forget I just said that. Across from the 60 is 9. Then what you have to do is you have to set that 9 is equal to A root 3. And so then the shortcut, remember the shortcut, divide by 3, multiply by root 3, okay? Divide by 3, multiply by root 3. So if I took my 9 and I divided by 3, okay, that's going to be 3 root 3. So A, this side right here, will be 3 root 3. That means across from the 90 is 2A. So if this is A, what's 2 times 3 root 3? Okay, so that means this value here is now 6 root 3. Okay, now what I was started to show you here was you can take 9 and instead of doing divide by 3 and multiply by root 3, you can always set whatever's across from the 60 degrees to a root 3. You just have to do the work then. You're going to divide by root 3. Root 3's are going to cancel. I get a equals 9 divided by root 3. But of course, you're not going to leave a root on the denominator. So you're going to multiply by whatever is on the denominator over itself, because that's 1, right? Root 3 divided by, I look at the denominator and I say, what's on the denominator? Root 3. So I need to multiply by root 3, because root 3 times root 3 is the square root of 9, and that's 3. And so whatever is the same value that you're multiplying with the root, it's going to, the roots are going to cancel, and you just get that number. Okay, so that's why we want to multiply by exactly the same thing. Now, on top, I have, 9 times root 3? So I have 9 root 3. I'm running out of space here. So I get 9 root 3 over 3. Now the 3's are going to cancel, right? You get 3. So this value would be 3 root 3. And so that's my A value. So, there's other ways to find it, but just keep practicing with the 30, 60, 90s, and definitely ask for help whenever you need that. So anyway, I hope that helped you. And this is day 2 of Pythagorean Theorem. Also 30, 60, 90 right triangle, special right triangles. Okay. All right. Thanks for watching.